Assalamu alaikum. Welcome to the complete solution of calculus session. In this session, we'd like to discuss problems from 5 to 25 from chapter 0.2, and we'd like to solve here. Let's have a look at the problem first. So in this problem, it's asking sketch the graph. So problem 5 to 25. Sketch the graph of equation by translating, reflecting, compressing, and stretching the graph of y is equal to x square root over x. And this appropriately, then use the graph utility to confirm that your case is correct. Okay, so we would like to solve the problem, discuss about this 5 and 9 in this session. So let's start. Like to solve 5 and 9. Right, so our our equation is given here. 5 minus 2x plus 1 whole square minus 3. So exercise 5 from chapter 0.2. The equation is given here, y equals to minus 2x plus 1 whole square minus 3. Okay. So the basic steps here, we first define the steps here, steps. So clearly the basic function is here, y is equal to x square. This is the basic. And can then get 2y equals to minus x square, which is a reflection about the x-axis, because all these y values becomes negative here. Number 3, we can then y equals to do minus 2x square, which is a vertical stretch by a factor 2. And then number 4, we can then draw minus 2 into x plus 1 whole square. So plus 1 with the x variable, that means we need to move the graph left 1 unit. And finally, we'll get our desired graph, which is y is equal to minus 2 into x plus 1 whole square minus 3. So we are adding minus 3 with this previous function. So this is actually down 3 units here. Okay, so let's start this drawing here, and we'll use the 3-point formula basically. So number 1, Number one is the next base. Number one, we're labeling this way. Y is equal to x square. We're drawing the basic one graph. So 3 points formula we are using. Okay, so and 1 minus 1, 0. So this is x-axis, this is y-axis. This is 1. So this coordinate is 1, 1. And this coordinate is minus 1. So this is the basic graph at 0, 0. So we will have this graph here. And this is 0, 0. Now in the second case, we'll draw this graph, which is actually the reflection about the x-axis. So all these y values now negative. So free and drawing, you can just, so minus 1, 0. So 0, 0 becomes the same, but minus 1. For 1, we get minus 1, and then for minus 1, we get minus 1. So this is minus 1, and then we have the graph here. So this is the graph for the second case. Now, number 3, we'll do y is equal to minus 2x square. So which is basically vertical stress by 2 units. So y becomes double in this case. So at 0, 0, it is 0. Now at minus 1, it's become minus 2. And also at minus 1, it becomes minus 2. So this graph is a vertical trace of the previous one by a factor 2. Now we'll draw the next one, fourth case. Number fourth case, we'll draw this function y is equal to minus 2 into x plus 1. So which will actually give us a left movement, 1 units to the left graph. So all these 3 points, so 1, 2, 0, minus 1. So minus 1 becomes here 0, 0, 0 becomes here this, and 1 becomes 2. So 1 minus 2. So at 0, 0 points now becomes 0, 1, and this becomes 0 minus 2, and then we'll have a point 2, 2 minus 2, and this is 0 comma 2, sorry, 0 comma 1. So the graph shifted 1 unit to the left. Let's draw this graph and similar pattern. See, just 1 unit shift to the right. Now the final one. Fifth one is here the ultimate graph. Y is equal to minus 2 into x plus 1 whole square minus 3. So we will do this very precisely using these 3 points again. So 0, now 3 units down. So 1, 2, 3, this 0, 1 now turn into this, and this 2 points again 2 units, and then here it is also 2 units. So 0, 1 now move into 0 minus, so 3 units, 0 minus 4. Yes, that is a mistake. So this is we did a mistake here. This point should be here 0. Writing the coordinate is silly mistake. So this should be 1 comma 0. Now this is the point here. We got 1 comma 3, and this is the coordinate. We got 0 comma minus 5, and we'll have another point here, 2 comma minus 5. All these points down 3 units. So we then join this, and so this is the graph for this given equation, and we discussed here very smoothly. Let's have a look again. So we all these things we have done. We first write down our steps, and then we label them. So that you can also mention the domain range here. So domain and range. Let's write the domain and range. So what would be the domain and range here? So domain, in this case, domain is all real number, and range is 0 to infinity. Now in this case, domain remain the same, all real number. So minus infinity to plus infinity, and now range, just reverse range here, minus infinity to 0. And when it's vertical stretching, domain range become the same actually. So you can easily write here domain is minus infinity plus infinity, and range is here minus infinity to 0. So here we have the domain, all real number, and range is minus infinity to 0 still remain, but here we have domain f is all real number, but range is changed here. Range f is now minus infinity to 3. So okay, now we discuss the solution of problem number 9, 3 minus root over x plus 1. Size 9, chapter 0.2. Y is equal to, here you can have a look again, x 3 minus root over x plus 1. So it is 3 minus root over x plus 1. So we can do it a little bit different way here. So first we'll draw the basic one, y equals to root over x, this function, square root function, basic. Okay, so what would be the graph? Again, 3-point formula. We'll take leveling x and y axis and the origin. So 1, 2, 3, 4. So let's take this point at 0, 0. At 1, it is 1. And at 4, the value is 2. So 4, we get 2. For 1, we get 1. So this is our graph. And second case, we'll draw y equals to root over x plus 1, means shift left, shift 1 unit left, 1 unit to the left, this previous graph. So we'll draw this accordingly. So the 0, 0 point will come here at -1, 0, 1, 2, 3, 4. So we'll get at -1, 0, 0, and we'll get at 0, we'll get 1, at 3, we'll get 2. So this is the 1 unit. Movement to the left, 0, 1. And this value is 1 minus 0. So we'll get this graph. Right. And so we can see the we'll discuss the domain range a little bit later. Now we'll do minus reflection of these things. Third case. So number 3, we'll draw root over minus root over x plus 1. So which is actually reflection. Reflect about the x-axis, and we'll have this draw. So we're doing so whatever we get at -1, 0. So reflection y value 0, negative is 0. So we get 1 there, and now we'll get 0 minus 1. So we get 1, 2, 3. For 3, we got 2. Now we'll get for 3, we'll get -2. So 3 minus 2. This is a reflection about the x-axis. So the graph is now this. Okay, so this is the graph for this case. And let's see how the domain range actually affect. We can discuss here. So at the beginning, or maybe later, first draw this graph. So and now we need to add +3 with this thing. So final stage. Y equals to 3 minus root over x plus 1. So up 3 units. This means we need to move the graph 3 units up. So the point, so we are using the 3-point formula, -1, 1, 2, 3. So when -1, 0, we get 1, 2, 3. So we have this now. So -1, 3, and when you got 0 for -2, now you got 0 for 1, and then 3 for -3 for, we get, you see in the previous graph the point. So 3 units up, -3, 2, and now we need to move it to -3 units up. So 1 units up, and we had, let's have a look again. So we got, sorry, we got -1, so it will be actually -2. So at 0, -1, so it will be -2. And so -2, we get another point 0, 2, -1 it was, and then now we'll get 3, 1. So this is the point, 3 units up, 3, 1. It was -2 previously. So we have this graph, and we can yeah, so at the point 8, it will be intersect actually z 0, Yeah, so if it is 8, then it will say like, if you find the x-intercept, so this is like this. So see now the domain and range cases. Domain range, we'll discuss the domain range in short. So all these functions, so see here, domain, how the domain range actually changes. So yeah, the domain is actually 0 to infinity, and range the same, 0 to plus infinity. Here the domain actually shift 1 units to the left, so -1 to infinity, and range is here 0 to infinity still, since the movement is horizontal. Now we have a reflection here, so that range is changed. So in this case, domain is same like in step 2, so -1 to infinity, and range f is -infinity to 0, and the last final step we got the domain and range. Domain is -1 to, sorry, -1 to infinity, and range is here -infinity to 3. So that's all for this session. Please share, subscribe, and follow us, and visit our website to get more updates. Thank you again.